And yeah, I think it's about time we can begin. Let me just remove these text. Oh, it's black. There I am. Okay, so welcome everyone. Like I said, so this is Math Pond. This is our exercises type session where we'll just be solving various exercises either from Discord or from the chat. And yeah, it's kind of a more like chill session. I'm not gonna like dictate, all the lecture answers. We're kind of well, I haven't prepared any questions, so really we're just gonna solve these together right now on the spot. And if I don't know how to do something, hopefully people in the chat can help me out. Um, so do we want to go to Jake's problem? I had another problem here real quick. I'm not sure which is the okay. Yeah, Jake posted this one. All right, so let's just go over this one since Jake just posted this, and then I'll do the other one in the submissions by Red Dot, a calculus problem. But yeah, let's look at this problem from Jake first. It says solve the equation. Sorry. Solve the equation x plus 1 times x plus 3 times x plus 5 times x plus 7 equals 9. So like this. X plus 7 equals to 9. Okay. This is give the work in full, reduce the answer to their simplest form, and write and arrange your exercise in legible and orderly manner. Okay. Pretty straightforward. So, yeah, this is the question. We want to solve for x, of course. Right? So yeah, I'm trying to figure out what's the point of this problem. I mean, they want an integer solution. I mean, maybe a little more context here would help, but I'm assuming maybe there's like some integer solution, but then again, product of four things equaling 9, that's, not possible with integers unless, yeah, right? Because 9 is a factor, this is 3 times 3, right? Hey, Rex. So 3 times 3, so yeah, I mean, there's gonna be a problem here if these are all integers, right? So that could be one way of viewing the problem. So what's the question? Is there a root in the rational numbers? Jake, you need to tell me the question. So, um, solve for x. So I think we determined there has to be at least one real root, right? Because if I plug in 0, I think I made some sort of argument. I can't remember what it was. So over the complex numbers, there should be 4 roots up to multiplicity, right? But I think the question is probably asking um, either, is there a rational root or is there a positive rational root? Something like that. Yes, it's a fourth power. Okay, so chat is saying 1 plus 7 is 8, 3 plus 5 is 8. I would use the common factor and narrow it down to a quadratic. Yes, it's a fourth power. What is a fourth power, Jake? I would do them all to C. Oh, check all the... So are you talking about the rational root test here, or let's be a little more specific? I'm a little confused, Rex. What are you saying here? 1 plus 7 is 8, and 3 plus 5 is 8. Okay. Yeah, I see that. I mean, the thing I'm looking at right now is we have a product of 4 things. They can't all be integers because they would have to be like square root of 3, square root of 3, square root of 3, square root of 3 or something, right? Um, which aren't integers, obviously. Foiling them all and subtract 9 and factor. Narrow it down to a quadratic. So, Jake, you're still not answering the question. I need to know what is the question? Like, am I solving for x as a complex number? Because, like I said, we know there's 4 roots over the complex numbers. We know there's at least there's at least one root, right? Because if I plug in 0, no, that's not true. But yeah, a little more context would probably help. Like, am I supposed to be factoring this? Do you want like a rational root? Something like that. Okay. So let's see. Oh, okay. So 1 times 3 times 5 times 7. Subtract 9. Okay. Well, I'll try some stuff and then maybe it doesn't work, but So what was your idea, Rex? Foil out like 2 of them separately, or what's? I would plug in check. Well, like we said, there's nothing we can plug in here that's an integer that would work. I guess maybe there's a rational number, but that seems unlikely. No, I guess it's possible. Oh wait. Yeah. What is 1 times 3? Yeah. Let's just establish what. I guess we could try plugging in numbers. No, it can't. It can't work for integers. Yeah, like I said before. Can we foil all of them? Yeah, I mean we can foil them. I'm just not sure where that gets us. I mean we can just write the whole product out and then subtract 9 from each side. I mean theoretically there is a quartic formula that gives you all 4 roots, right? So we could just plug it into the formula and get the answer. That's why I'm asking like what's like we need a little bit more information like about what I'm not sure what the problem's trying to get me to do. I mean, you can go to Wikipedia, look up the quartic formula, right? Just plug in all the coefficients, and then you get your 4 roots. But that's probably, I feel like that's not what we want to do here. Oh, what did I miss? Can't we foil all of them? Okay. Foil all? Yeah, just multiply them out. Okay. Yeah, I guess. Yeah, let's just write it out anyways. I guess if it doesn't get us anywhere, then it doesn't really matter. But okay, so 5x plus 7x, 12x, right? Plus 35 is 9. Should we multiply these together now? It's probably, if you group 1 and 4 and 2 and 3, then they both add up to 8 in the x sum. If you group 1 and 4, what do you mean by 1 and 4, Rex? If you group 1 and 4, multiply by each pair. Oh, just each pair separately? I mean, it doesn't really matter how we get the whole thing. I think this is fine. So x to the 4th plus 12x cubed. I mean, I was trying to avoid all of this, but yeah, 4x cubed 48x squared. Whatever 4 times 35 is, what is that, 140? 140x. Plus 3x squared plus 36x plus 3 times 5, what is that, 90, 105? Okay, where does that get us? If you group one and four, each pair, this question is also... Jake, what are you saying? This question is also ready 157 years old. Not sure what you're trying to say. Oh, I see how I was supposed to figure this out. Stooky, can you help me out here? I feel like I'm missing something here. I would just say stick it in the quartic equation. I'm not dealing with this, but I guess that's not satisfactory to the gawking rabble. It's already 157 years old. Well, Jake, I mean, this is your problem. If you don't want us to do it, I mean, we can just skip it right now. I mean, this is, you wanted me to do this. It's 1869. Do P over Q. Okay, yeah, I mean, rational root test, right? That's what we're doing, right? Is that the way we want to go? Root theorem, whatever, yeah. Okay, so we subtract 9 from both sides to get a 0 here. This will be 96, right? Do we care about combining all the other stuff, or what do we need? It's just about, can someone remind me, it's about the first coefficient and the last coefficient? I mean, spoiler, spoiler. I can't read that. I learned just recently. What do you mean by P over Q? I thought that's what you meant by rational root theorem. Okay. Yeah. Factor of 96, a factor of 1. That should get us places. Okay, so yeah, let's just remind ourselves what is the rational root test. I always have to remind myself this. This is honestly something I forget a lot. So let me just look it up again real quick. Maybe I'll share the screen. Just so we get it correct. Oh, it's already there. I've already looked it up and I still can't remember it. Okay, so we have a... See, but Jake, this is why you need to include all the information about the problem, right? Because you need to tell me we're looking for a rational root. I mean, if you just give me a polynomial, say solve for x, I mean, I could just plug it into a quartic equation, get a possibly irrational root, right? Okay, so we're looking for rational roots of this polynomial. We have our polynomial written on the board, which you can't see right now, but the first coefficient is 1. And the last coefficient is 96. So the theorem states that each rational solution x equals P over Q, written in lowest terms, that is P and Q are relatively prime, satisfies P is an integer factor of the constant term A0. So that's 96 for us. So P divides 96. And also Q divides 1, so Q has to be 1, basically. Yeah. Okay, and yeah, that restricts us, right? So then we're very restricted to what can happen here. Yes, use rational is quickest. So x equals -8 plus or minus square root of 64 24/2? Oh. Wait, what are you guys saying? Jake, so P has to divide 96, but we already said there's no integer solutions, right? It has to be P over Q. This is saying it has to be an integer, so. Since your problem is ill-formed, I mean, I'm just gonna say, this is the answer. There's no rational roots because they would have to be, integer division. They would have to be integers and would have to divide 96. But we already said there's no product of 3 integers that equals 9, so it's just not possible. If you want an irrational root, then okay, then we can just stick it into the formula, or we can try to factor this into like 2 quadratics or something. But I mean, you need to specify. Does anyone disagree? Am I totally off on this, or does someone want to chime in? I don't know. Stuki, is that the same? Does that agree with your what's going on with what you looked at? I see this. It's a spoiler here. I can't read this though. Satric substitute. Yeah, I can't even read that. I don't understand the -8 plus or minus square root of 64. Try x equals 4. 5, 7, 9, 11. I get x minus 4 squared. I don't know where you're getting these numbers. And x equals 4 doesn't work, right? The product of these 4 numbers is not 9. In fact, I'm pretty sure my argument holds up. I don't see... The product of any 4 integers is never going to be 9. So... yeah, just 9 is not possible here if these are integers. It's possible that x is some irrational number. That's still possible. Could be the root of a quadratic, or the root of maybe this is the minimum polynomial for it. I made a mistake. It's -4. I still... You think the answer is -4 or the... I don't think -4 works either, right? It's same problem, right? -3, -1, 1. Oh right, I forgot they could be 1. Okay, good point. Yeah. Okay, yeah, I'm wrong. Yeah. If there weren't 1, then it wouldn't work. But yeah, I forgot they can be 1. That works. Okay. Right. All right. I guess we should have just plugged in check from the beginning. Right. Okay. Yeah, my reasoning was pretty bad there. Yeah. So what should we have done from the beginning? Probably just checked a bunch of small numbers. Yeah, I mean, I guess if the product of the 4 numbers is 9, I mean, they can't be too large, right? Because each of these numbers has to be smaller than 9 in absolute value, at least. Okay. Yeah, I'm satisfied with that. I want to say it was tricky, but it really wasn't. I just wasn't doing it well. Right. So wait, does this just factors into x plus 4? I guess, this is probably just x plus 4 to the 4th, right? Is this the only root? Oh, I guess I gotta look at all the Yeah, I gotta combine everything. There's a lot of x's here. I think this is maybe just x plus 4 to the 4th power equals 0. But I'm not sure. Maybe not. Alright, there's 2 more. Yeah, hold on. We have one more problem to do here. I can look at another one from you, Jake, in a second, but I wanted to look at this one from Red Dot in the Discord. Right, so this is a pretty standard improper integral from calculus. So we're taking an integral from 0 to 1, and it's 1 over x to the 0.9. 0.9 dx. And the point is that it's an improper integral because the function's not defined at one of the endpoints, at 0. But that's okay. We can view this as like a limit as epsilon goes to 0 of like an integral from epsilon to 1, the same thing. Right, and then you just have to remember with these, I just remember that this power here, this 1 over x to the p, you just have to be careful. There's 2 different cases, whether, well, really 3 cases. If p is greater than 1, if p is equal to 1, and if p is less than 0, or sorry, less than 1, I mean, greater than 1. Right, so 3 cases. In this case, you can just find the antiderivative. Well, actually, probably in all the cases, you can just find the antiderivative, and that will help you out here. So this is, what's the antiderivative of that? If anybody is still paying attention. All right, so these ones we can use power rule, right? And this power rule will help you remember why these 3 cases exist. Yeah, so power rule will still work. Yeah, exactly, yeah. So power rule still works because once you take this limit, it's just a normal integral. It's just a limit of a bunch of normal integrals, right? So each one of these integrals we can just view. Normally, this has an antiderivative, right? According to the power rule. And once we apply the power rule, then the problem becomes pretty trivial, right? Yeah, x to the negative 0.9 over negative 0.9. Not negative 0.9. No, we need to raise the power by 1. So yeah, it's x to the negative 0.9. Initially, we need to raise the power by 1, right? It's sort of like the inverse power rule, so you need to be careful, right? The original power rule says that when we take the derivative, we get n x to the n minus 1. But then when you go backwards, you kind of have to undo that. So you actually have to raise the power by 1 first. So it becomes x to the 0.1 and then divided by 0.1. So raise the power by 1 first, then divide by the power. It's the opposite way that you would do it for the normal power rule. Not 1.09. Nope, still wrong. Getting closer though. It's positive now. Okay, and then if we plug in 1 now, this is just a limit as epsilon goes to 0 of 1 to some power divided by 0.1, which is times 10, so just 10 minus 0. Or not minus 0, but something that's going to 0. 10 times epsilon to the 0.1, right, which equals 10 minus 0. Right, because epsilon is to a positive power, so when epsilon goes to 0, this thing is just going to 0. So that's why you have to be careful with the power rule. If this power is bigger than 1, then this doesn't work anymore, right? So that's how you basically remember it. And if the power is exactly 1, does it work or does it not work? If this p is exactly equal to 1. Where did we get the second 10e at? So this notation means we take the antiderivative, then we plug in 1, and we subtract plugging in the bottom point. So this is the fundamental theorem of calculus, right? We take the antiderivative, then we plug in the first endpoint, subtract the second endpoint. Or plug in the second endpoint, then subtract plugging in the first endpoint, actually. So we plug in 1 here. So 1 to the power of this is 1, divided by this is 10. Then we subtract off, we plug in epsilon, we get 10 epsilon to the 0.1. But this part's just going to 0. So in the limit it's 0, and that's just 10. After the factoring of what I showed you, I get x squared plus 8x plus 6. Jake, what are you talking about? Which problem are we talking about? Oh, in Discord? I'll get to it in a second. You understand the first 10, but where did the second 10 come from? There's a 10 for both. It's divided by 0.1. So 10 here, 10 here. Just plug in 1, you get this term. Plug in epsilon, you get this term. And the divided by 0.1 is in both of them. I mean, you could always, of course, you could factor it out. But, all right, so Jake's, I'll leave this problem up for now, but if no one has any questions about this, we'll move on. But yeah, when p is 1, you have a problem, right? Because then the antiderivative is the log of x, and if you try to do this, you'll be subtracting negative infinity, and it won't converge, right? So you have a problem for these types of integrals if p is 1 or if p is greater than 1. And then if you have the bounds the other way, where the lower bound is 1 and the upper bound is infinity, then it's the other way around. So p equal to 1 still doesn't work. And then you have a problem if p is less than 1, going the other way. But yeah. Stuckey says, I have a not exercise question. What is meant by a central limit theorem? I've heard people say this, but I don't know what else you might want besides what the Introstats CLT already says. Yeah, so I was looking at this before. I'm not an expert in this, but I know there's a couple tweakings you can put on the central limit theorem. The one I proved yesterday, we had to assume that all the random variables had moment generating functions that had some radius of convergence. And I think it said something, there's a more general version where maybe they're not independent necessarily, but like they're all uncorrelated, or there's some sort of weaknesses you can put on the fact that, so the very strict one is the fact that they're all, like all the moments exist. But I think you can get rid of that condition, because I think all you need is that the mean is finite and the variance is finite, and then you can use the characteristic functions and prove it that way. But yeah, I'm not an expert. I think it has to do with the different things that you can sort of drop from the assumptions and still get the normal distribution in the limit. So it's basically like, what's the most general statement we can make where when we sum up all the variables, it's still normal? Because of course, if you don't assume finite mean or finite variance, then you can sum up the variables and get something that's not normal. So yeah, that's the best of my understanding, at least. Yeah, the independence assumptions, maybe you can drop a little bit of something about the independence. Maybe they're just uncorrelated or something. Or some of the other assumptions, you can try to weaken those somehow. Okay, so nothing left on this problem, I think. I don't see anything in the chat. Let me look at Jake's problem here. Oh, he put it in the general. Oh, this is his solution. Okay. Yeah, let's put this on the screen real quick. Okay, I'm just looking at this right now. Okay, so Jake's saying he factored out... Oh, okay. So it's not x plus 4 to the 4th. Jake's saying he factored out an x plus 4 twice, I'm guessing. Okay, he did synthetic division here in the corner, I believe. Not really sure if I have time to check all of this, that it's like fully correct, but it looks like he's taking the right approach. So he found one root just by checking, which is what we should have done at the beginning. I was just thinking of it stupidly. So we plug in -4, we get a root, and then you find out that -4 is also a root of the remaining function when you divide out by it using division. And then he's saying that then you end up with this quadratic, and this quadratic has irrational roots. It has roots -4 plus or minus square root of 10. So yeah, this looks like a pretty good solution, assuming that all of this is correct. Here he's showing the P over Q method, where Q had to be 1, and then these were all of the factors of 96. And then and then the plus or minus is important, so we have to check all the plus roots and all the minus roots. So I should have been careful and checked that. My argument would have worked before if we assumed all these numbers were positive, but they don't have to be, because x being -4 means you get a negative number for the first two. Okay. Any questions about this stuff? Oh, I can't make it smaller. Oh, there we go. Yeah, Jake, we just went over it. Did you see that? So, and you got 100 on that. Okay, yeah, perfect. Yeah, I mean, it looks good. Yeah, I didn't check every little detail of it, but it looks like you took the right approach for sure. Okay, so do we have any other problems? I think I saw one on Discord. Let me check. There was another one on Discord from like last week, I think. I never got to it. Where was it? Oops. Oh yeah, I'm not sure. Oh no, that was the one we just did. Oh yeah, this compounding interest one. Oh, we can do that one after. That one's kind of boring. Oh, right. And then we had these. Stooky, did you have any problems? I think you said you had one, right? So did x to the 5, that has 35 possible solutions. Pre-calc, okay. Okay, so I'm looking at this problem here. There's some probability ones. Okay, let's just look at this one for now. So probability task 13, I'm looking in the Wednesday submissions. So this is task 13 by that snake JNDR. All right, I'm just gonna write it on the board, so I need to look at the screen for a second. So that Jake JNDR And the problem is task 13, so 13.1. So an urn contains 12 identical balls. Identical balls. Each marked with exactly one unique integer. We draw 3 balls, one by one without replacement. Without replacement. Three balls, one by one without replacement. 13.1 asks, among the drawn balls is the smallest number from the urn. 13.2, the second drawn number is largest than the first and at the same time smaller than the third. 13.3 says the third drawn number is either the smallest or the largest of the 3 drawn numbers. Okay, so we want the probability of each of these. Among the drawn number, one unique integer. Oh, with one unique integer. Okay, that's important. I missed that part. Okay, I think, right, no, I know. I'm just writing down the problem. Okay, got the problem here? Can everyone see this? Okay, so we have an urn contains 12 identical balls, each marked with a unique integer. So each one has a different number on it. I guess they can be negative. I don't think that matters much, but we draw 3 balls, so without replacement. Okay, so we're taking 3 balls, and so 3 of the 12 will come out of the bag. And then we want to know what's the probability. 13.1, so what is the I'm assuming that they're asking what is the probability. Of the following. And 13.1 says, among the drawn numbers is the smallest number from the urn. Okay, so we want to know, can everyone see now? So we want to know, I'm pulling 3 balls. You know, there's another 9 balls, so it's either the case that the 3 I pull, the smallest one is either in that set or it's out of that set, right? So it's a binary possibility, right? But we have to be a little bit careful, right? Because we have the without replacement condition here, right? So that's going to change the odds. When we pull the first ball out, either we're gonna have gotten the smallest number and we like win the bet, right? If you think of it that way, or we don't get it and then we have to go back and go for another try, basically, right? So, yeah, with the first ball, what's the chance that the first ball I pull out is just the smallest number and I basically like win automatically? What's the probability of that? So I guess you could sort of think of it probably in 3 cases. Not 100% sure about this, but it seems like you can just split it into 3 cases, or I guess 4 cases. Either you get it on the first one, you get it on the second one, or sorry, either you get it on the first one, or you don't get it on the first one, then you get it on the second one, or you don't get it on the first one and the second one, and then you get it on the third one, or you just don't get it on all 3. So that's the the four things that could happen essentially. Yeah, so I think that probably is enough hint to get the answer from there. Does anybody want to be brave and guess at the answer, or try to, you know, bring us along to the next step here? So we have 12 balls. Yeah, I guess I can just say, let's just talk about what's the probability picking the smallest ball. Just on one pick, right? That's a 1 out of 12 chance, right? But that's just for one ball, and we're drawing 3 balls here, so we need to be a little careful. So first ball, 1/12 chance, I pick the smallest ball, and an 11 out of 12 chance that I don't pick the smallest ball. So it's a 1 out of 12 chance plus the chance that I don't get it and then I get it on the second one, plus the chance that I don't get it on the first two and then I get it on the third ball. And then we're not going to add in not getting it because, yeah, if we don't get it, then we don't want to add that probability in. So somebody in chat says 1/4. I didn't do this problem out yet, so that could be correct. But yeah, so I'm guessing it should be about 1/12 to get it on the first one, plus 11/12 times 1/11 to get it on the second one, plus 11/12 times 10/11 times 1 out of 10 to get it on the third. And this, I believe, should be the answer. Oh, wait. Is that right? So 1 out of 12 chance to get on the first one. If I don't get it, it's an 11 out of 12 chance, and then I have to get it on the second one. That's a 1 out of 11 chance, or I have to get it on the third one. That's a 1 out of 10 chance. I think that's right. I don't think that adds up to 1/4 though. Yeah, 1/4 is high. Yeah. Yeah, it should be like slightly less than 3/12, I think, or maybe slightly more. Oh wait, 3/12 is 1/4, right? Yeah, I don't think it's exactly. Oh, okay. Yeah, I think you're just adding them, right? Yeah, you can't do that. Yeah, you can't just add 1/12 plus 1/12 plus 1/12. That's definitely not correct. It's closer to 1/12 plus 1/12 squared plus 1/12 cubed. Yeah, that sounds correct. Right. Actually. No. It is pretty close to 1/12 plus 1/12 plus 1/12. It's just that these factors are not exactly 1. Oh, wait. But we're actually adding something slightly bigger than 1/12 also. So yeah, it should be pretty close to 1/4, but I don't think it should be exactly 1/4. No, that expression on the board is definitely just 3/12. Is it? Oh, we only get 3/12. Oh wait, it is only 3/12. It is just 3/12. Oh wait, why did I say 4/12? Oops. Yeah, 3/12 is 1/4. Yeah. All right. Well, now you guys are making me guess this, so I have to type it in the calculator. Just because. And I'm also too lazy to do it out. So. All right. So 1/12 plus 11/12 times 1 over 11 plus 11 twelfths times 10 elevenths times 1/10. Wow, it is 1/4. All right, I stand corrected. Wow, I'm just looking really bad today. I was looking at it, I'm like, oh, it does look like it could be close to 1/4. Okay, all right, fair enough. I mean, if you draw 3 balls out of 12, isn't that 1/4 chance? It would be lower if you did replacement. I haven't thought about the actual question, just a comment on the arithmetic. You're watching another stream. Without replacement is the same as choosing 3 out of 12. Right. Because it's without replacement, so we're basically just picking 3 of the balls. Right. It actually gets more complicated if it's with replacement, right? Is that that's the issue? Yeah, because with replacement, you need to think about the fact that. Well, no, that's. I don't know if that really changes anything, does it? You're still just trying to get the. I guess you could get the. Yeah, there's like. If you replace it, I guess you could pick the smallest ball like all 3 times, and that would be like something that couldn't happen the other way, but. I don't know. With replacement is the other case. Yeah, I'm a little confused about what happens like with replacement because I was thinking that this was the more complicated one, but now it's basically you're just telling me I can basically just check the chance of getting 1 and then I just multiply by 3, right? Because I'm picking up 3 balls. If I picked 6 balls without replacement, that should just be 6 over 12, right? I mean, I'm picking half the balls, half of them are in my set, half of them I didn't pick, and I basically have a 50-50 chance to pick the smallest ball. Because I picked half the balls, and the other half are outside the set, right? Having now read the question, it is strange that it's exactly 1/4. I grant you that normally that kind of intuition doesn't work, so I'm curious what it is about this particular problem that makes it okay. Yeah, but no, I think it does work with this because it's without replacement. I think if you change it to with replacement, then yeah, or maybe there's just some weird combination of numbers that it just happens to equal 1/4, or yeah, or it just happens to equal 1/12 plus 1/12 plus 1/12. But that seems very odd. I mean, obviously you could probably pick the numbers so that it happens like by accident. I think it's just picking 3 out of 12 at the same. Yeah, that's what I'm thinking. Is it just picking 3 out of 12? Like if we changed it to 6 balls without replacement, would it just be 6 out of 12? I think it would. So maybe it's if you change this to with, then it gets more complicated. Because if it's without replacement, then it just seems like you're just picking some proportion of the balls, and whatever the chance is that you get it on one of the balls, if you pick multiple balls, it should just multiply the probability. But yeah, there's usually you don't want to do it that way. That's why I was trying to not solve it that way because that's usually the way they word the problem to confuse you. But in this case, it actually just worked out. I think without replacement, you're just picking m out of the n. Yeah, and then whatever the probability of picking 1 is, it would just be m times that, right? Without replacement makes it harder, I think. Yeah, with replacement does make it harder. You're right. Yeah, so that would lower it. Yeah, because you're putting the ball if you didn't get it on the first one, you're putting it back in there, and so you have another ball that you can pick to not get the lowest one. Yeah, correct. Yeah, that's correct. Yeah, so I guess with replacement would lower the probability, so it would go from 1/4 to something slightly lower. Yes, that's your scale. How many balls? Okay, I think we're good on this one. Does anyone have any other problems we want to go over? Anyone's from the Discord? Or any... Oh, wait, no, sorry. There was another part of this. Yeah. Oops, my bad. So there's two more of these. Okay, so we did part one. The second drawn number is larger than... Okay, let me write this out. (13.2) says the second drawn number is larger than the first. And at the same time smaller than the third. Larger than the first and smaller than the third. Okay, that's interesting. So if we pick, let's say the numbers that we draw are D1, D2, and D3. So we want that D2 is bigger than D1, but smaller than D2, or D3. Right? Second drawn number is larger than the first and smaller than the third. Second larger than the first is 50-50 by symmetry unless the numbers repeat. Are these questions posted anywhere? Yeah, they're on the Discord. Yeah, so they're in the Discord, which you can get the link right here. And they're in the Wednesday section. Yeah, like Sticky says. 6 permutations, exactly 1/3 have second between the first and third without replacement. Just scroll a bit, they were posted on 211. Okay, yeah, so what is there's 6 permutations that these 3 numbers can be in, right? D1, D2, D3, or D2, D1, D3, or D3, D1, D3, etc., right? So if we pick them randomly, we'll get one of those 6 permutations, and it should be uniformly random, right? Because there's no one permutation that's favored more than the other, right? Yeah. These are all unique numbers. And if I pick 3 of them, I should get some permutation. I just don't know which permutation I'll get, but they should be all equally likely, right? Each number is equally likely to be in the middle, right? Yeah. Yeah, so I like the way Jeff started out here. He says second is larger than the first is a 50-50 chance. Right, so second larger than the first is a 50-50 chance, which we need to be true. Otherwise, this doesn't work. And then also we need then the third number to be larger than the second, which is not 50-50. Okay, so that's the other probability we need. So it's going to be 1/2 times something. Should it just be 1/6? Yeah, because this is one particular permutation, right, out of the 6, and I think, yeah, by symmetry, each number is equally likely to be in the middle. I'm thinking it's 1/6. Or is there some double counting that needs to be done or something? Or that was done? Let's see. Yeah, how do we prove that? I feel like it's 1/6, but I'm not sure. Is there like a slick proof? So that would be implying that the probability I was going to multiply by here was going to be 1/3, right? If the answer is 1/6. So 1/2 chance that you get D2 bigger than D1, and then I guess there's a 1/3 chance that D3 is then bigger than D2. Why is that the case? But it's symmetric for all three. So maybe I'm wrong here. Maybe my reasoning is incorrect. It is 1/6. Okay, never mind. Yeah, so my intuition just says that if I pick 3 random numbers, I'm going to get a random permutation, and I'm going to get all possible permutations uniformly. Is that true? Yeah. Yeah. So to get this particular permutation should be a 1 out of 6 chance, because it should be uniform. Yeah, that sounds right, but I don't like that as a proof, really. 1, 2, 3 is the only permutation that meets the conditions. Yeah, exactly. I want to formalize that, though. Is there a better way to formalize that? I guess you would have to be relying on the statement. You would have to prove first that the distribution of all possible permutations is uniform, and then you have 6 of them, so you know that this one is the only one that satisfies that, and there's only 1 out of the 6. But yeah, I think you would have to prove that's uniform, or else maybe what I'm saying is not true, right? Is there a simpler proof? Is there a quicker, like a 1 line, boom, done? Because I feel like that's a little bit hand wavy. Sort D1 through D3 and then use their ordinal position. Is it obvious that the distribution is uniform? I guess it's kind of obvious. Yeah, as long as the numbers don't repeat, I guess it is obvious, right? Because of the unique integer part. If they weren't unique, then and you had like less than or equal to here or something, that would definitely change the problem. Oh, and again, yeah, it's without replacement, of course, yeah. So why is picking D3 bigger than D2? Why is that a 1/3 chance then? I guess maybe we can reason about that. Because if we can prove, I think what Jeff said is correct, that if we pick D2 bigger than D1, that's going to be a, oh wait, why is that a 1/2 chance? Maybe that's not correct. Is that a 1/2 chance? Oh, because there's 12 balls. Okay, yeah, we're fine. I think you need an even number here, actually. Otherwise, it wouldn't be true. D2, D3. Yeah, does this depend on the fact that 3 divides 12 or 6 divides 12? You might actually need that, I'm not sure. Like if you roll 3 die instead of unique numbers, D3 has to be bigger than both D2 and D1. Oh, right. Yeah, but once D2 is bigger than D1, then we don't care about D1 anymore. Because if D3 is bigger than D2, it's automatically bigger than D1. So I'm not sure if that matters. Yeah, I feel like there's like a 1 line proof that says, so we know, actually, yeah, why is D2 bigger than D1 1/2? Because I think it's the same argument, but it's not obvious to me. It's equally likely that D2 is greater than D3 and D3 is less than D2, but we're predicating that D1 is less than D2. Oh, I see. Right. So it's equally likely that D1 is less than D2, and because of the symmetry, it's a 1/2. Okay, I see. Yeah, that makes sense. So by symmetry, D2 is bigger than D1 1/2 of the time, because the other half of the time, D2 is less than D1. Right, okay, I see. That makes sense. So then D3, you can use the same argument. D3 is less than D2 1/2 of the time, but it's also less than D1 1/2 of the time, and there's some overlap with those 1/2s, right? Jeff is saying the problem is that it's equally likely that D2 is greater than D3 and D3 is less than D2, but we're predicating that D1 is less than D2. Isn't it harder to be bigger than D2 if we already know D2 is bigger than D1? Harder to be bigger than D2 if we already know that D2 is bigger than D1. I guess it's slightly harder, yeah. Either D1 is less than D2 or D2 is greater than D1, but then why is 1/3 chance that D3 is greater than D2? Yeah, so we would either have to argue that the D3 greater than D2 has a 1/3 chance, or we have to do some sort of argument about the uniform distribution of the permutations. I feel like the cleaner argument is probably to just argue that the if I pick 3 numbers and I get a random permutation, that this random distribution of permutations is uniform, and then there's 6 possible ones. I think this argument does depend on this being 12, though, because if this is not 12, then you can't do that 1/2 argument, right? Actually, does the 1/2 argument even work with 12? Maybe it doesn't, because your symmetry argument doesn't necessarily work, does it? Or no, I guess it does. Yeah. Yeah, because either D1 is less than D2 or D2 is less than D1, and those have to add up to probability 1. So, and they're both equally likely, so they're both 50-50. Yeah, I guess if it's an odd number, then it wouldn't be 50-50 anymore. What would change? So yeah, one of them would be bigger than 50-50? How would that work? No, that doesn't make sense. Oh, okay, never mind. Yeah, I guess the 12 doesn't matter. Yeah. Oh, we got a raid. Okay, sweet. Right. Yeah, I just realized, yeah, even if this is odd, the number of permutations of 2 things is still even. So, yeah. Or the number of, yeah, like 12 choose 2 is still even number. Yeah. Okay. So yeah, do we still want to argue about this? I would try to argue that okay, you have all these possible permutations. The distribution of them, if I do this drawing 3 balls thing, the permutation that I get is random. It should be uniformly random, and there's 6 of them, so it should be a 1/6 chance. But of course, that is a little bit hand wavy if you don't prove, the uniform distribution part. Yeah, so I'll stay on this one if you guys want, but I think there's one more as well, which is interesting. Now solve it for 3 dice. We could do that in a second, possibly. All right, welcome Raiders. We're looking at this problem right here. I'm just finishing up a probability problem. Oh, it's only showing the page. It's not showing the problem. Oh, I thought it was showing my Discord. That's why. My bad. I see what the problem is. Okay. Right. Let me just write down this problem. Okay, so 13.3. The third drawn number is either the smallest or the largest of the 3 drawn numbers. Okay. So yeah, if anyone's just tuning in, we're trying to calculate these probabilities. We have a some magical urn. It has 12 identical balls, but they all have a different number written on them, different integer. And then we draw 3 of the balls without replacement. So we pick one ball, we don't put it back. We pick another ball, and then we pick a third ball. And then we were trying to calculate probabilities. What based on what the ordering of them was for the last problem, and we had a previous problem as well. So 13.3 says we want the third drawn number is either the smallest or the largest of the 3. Okay, so we pick 3 balls, and then the third number that we pick, it's either the case that it's the smallest of the 3, or it could be also the biggest of the 3. And we want to know what's the probability that that occurs. Jeff says, so 1, 2, 3, 2, 1, 3, 2, 3, 1, 3, 2, 1, so 2/3 chance. The third ball must be highest, lowest, or middle. Oh, okay, yeah. There's only 3 possibilities. So the third ball that we pick is either the smallest ball, it's the largest ball, or it's in the middle, and we want to get rid of that middle chance. So Jeff's saying that there's a 1/3 chance that it could be in the middle. So the other 2 are 2/3. Chance of being in the middle is 1/3. So yeah, why is the chance of being in the middle 1/3? I guess that's sort of like the same answer we got for the last one, right? Because we were picking the third ball, and the chance that it was exactly in the third position was a 1/3 chance, right? So I feel like this is sort of similar, except now we're trying to pick the third ball so it's exactly in the middle instead of exactly at the end. Yeah, so I like the answer 2/3. I just kind of want to justify it a little bit more, maybe. Seems good to me. So it seems like the chance of getting it exactly at the beginning would be a 1/3 chance, exactly in the middle would be a 1/3 chance, or exactly at the end would also be a 1/3 chance. So if we want this chance or this chance, that would be 1/3 plus 1/3. And the chance that it falls in the middle is 1/3, so that's the 1/3 that's missing here. Yeah, how do we prove that though? The third drawn ball is either the smallest. I guess, is this another symmetry type argument? We want to argue maybe the same way as the last one? Yeah, same symmetry argument, right? Yeah, only 3 possibilities, equally likely. Exactly not in the middle. So I like the symmetry arguments with these. I think that does work though. I'm just trying to think about the problem a little bit more. Three balls, 1 by 1 without replacement. Third drawn number is either the smallest or the largest. Yeah, I feel like I need to think about this one more. I'm not 100% sure on this one, but I'm like 90% of the way there. I like the answer 2/3, but I think I would need to write it out a little bit to be careful. There's definitely some symmetry going on here. I agree with two balls. You know, which one is bigger than the other one should be 50-50 because of the symmetry. Three balls, yeah, the ordering, yeah, it should be 1/6 to get a particular ordering. And here, yeah, it makes sense because there's 1/6 chance to get a particular ordering, and then we don't care about the ordering of the first and the third one. So they could be in this order or that order. So it should be 1/6 from the last answer and then times 2, because there's two possible orderings that give us this answer. Right. So this one, I think you can view these all as permutations. So this one, we're going to have some permutation. It's either D1 less than D2, is less than D3 is less than D2, or D2 is less than D3 is less than D1. So we have two different permutations here, and either one of these will satisfy this answer. And since there was a 1/6 chance for any particular permutation, and there's two of them, it should be a 2/6 chance. So yeah, I think maybe the proper way to view all of these is using some sort of symmetry argument, and then we need to count the number of symmetries, of course, which is n factorial, and you just need to show which one of the permutations satisfies the, or which number of the permutations satisfies the thing here. In this case, it's 2 out of the 6 permutations. But the third ball has to be less. What do you mean? Has to be less than D2 or less than D1, or in this order? D3 has to be less than D2 and greater than D1, or it has to be less than D1 and greater than D2. So either of the two cases. Oh, sorry, wait, did I write this wrong? Is either the smallest... Yeah, oh, right, I wrote this wrong, yeah, thank you. Right, it's the other way around, right. So D3 is less than D1 is less than D2, or D3, or D1 is less than D... Wait, what am I doing? Oh, right. There's actually 4 permutations. My bad. 4 out of the 6 permutations. Okay, let me erase this because this is wrong. Yeah, thank you, chat. Constantly correcting me when I do stuff wrong. It's great. The third drawn number is either the smallest or the largest of the 3. So either D3 is at the beginning, so then we have D1 and D2 here in any order. So it can also be D3, D2, D1. Or we have D3 last, which means we have D1, D2, D3, or D2, D1, D3. So we have 4 different permutations out of the 6 that are possible. Since it's uniform among all the permutations, we have 4 out of 6 possible permutations, so it should be 4 out of 6 should be the probability, which is 2/3, of course. But the third ball has to be less. Opposite of that, but yes. If the first 2 are 11 and 12, what's the question? My sense is that you look at all orders, you'll see choosing 11 and 12 first falls into the 1/3 of cases where it doesn't work. What do you mean 11 and 12? Oh, well, I guess we can order the numbers like 1 through 12 if you want, yeah. I don't know why they said like with one unique integer. They could have just said they're labeled 1 through 12. I don't know why they had to say it that way, but. So yeah, any questions about this? We have 4 possible permutations that are good for this, 2 that don't work, so 4 out of 6. And you just, of course, this depends on each permutation having a uniform chance of occurring. 1, 2 has to be greater. Hey, maybe they're using really weird integers. Well, yeah, that's what I was thinking. I'm like, okay, well, unique integers. I mean, okay, so the first one's maybe that's like negative, a billion and 6. I mean, what's the point, right? It should just be 1 through 12. I mean, you can just order them, right? And then there's a bijection between 1 through 12. It's the same problem, so. Oh well. Mathematicians like to add unnecessary stuff sometimes. 42, 57, yeah, 69, 67, of course. Yeah, 420. Any other probability problems, or where do we want to go from here? Probably have enough time for maybe one more. Let's do like a calculus problem or something. Does anyone have a calculus problem? I don't want to do any of these long word problems either. Geometry of glued solids, maybe? Sounds like a lot of drawing though. So Rex posted this 5th degree polynomial, but I think we had talked about this one already. I can't remember though. Oh, right, I can do this one if there's no other ones. Okay, yeah, so we had this compounding annual growth problem for a stock. This kind of goes along with what I've been talking about in the like lecture parts, Tuesday and Friday. Oh, excuse me. Squeaky eraser. Okay, so yeah, I had this Tesla problem. So it says in the past 5 years, so Tesla's stock was up 45.89%. %. And we want to know, what does that translate into as a compounding annual growth rate? Meaning that if the stock went up some percentage each year and I compounded that each year, what would the average, so what would it need to go up each year as a percentage to equal this if I'm doing the compounding every year and it's increasing for 5 years? So we want to know, what is the compounding annual growth rate as estimated by this period? Five-year period. Okay. And I guess it went up $133, so it started out like, what is that, almost like 290-ish, then went up to 422 according to this picture. Jeff says 1 plus x to the 5th is 1.4589. Yeah, that sounds correct. Yeah, so let's just explain that formula, but yeah, that sounds like the correct way to go. So what we're looking for is some percentage greater than 1, so some return r, that if we had gotten the return every year and we compounded it 5 times, so we got 1 plus r return, and then we compounded it 5 times by multiplying by 1 plus r again, 5 times. And this should be the total growth rate for the whole period, which was this 45%, 4589. And then we just want to solve for what's this annual return. So here r is the annual return, and it gets compounded for the 5-year period. So that will give us this compounding annual growth rate. Hello, Kyler. Welcome to the chat. And back of the envelope, increase of 45.89% is about square root of 2. So 10 years to double. So very roughly 7.2. Oh, that's a pretty good estimate. Yeah, I think that's pretty close. Yeah. Yeah, rule of 72. I remember my dad using that like a really long time ago. Rule of 72 only works for what? Percentages that are not crazy high. right? Because you're basically using a linear thing to estimate an exponential, right? So it should only be a good estimate for small percentages, I think, right? Okay, yeah, so let's solve this. So with a calculator, it's pretty easy. You can just take the fifth root of this and then subtract 1, and you get r. So yeah, let's do that. So r should be 1.4589 to the 1/5 power, and then I subtract 1. So this is, which I did not do right now, but we can do on Wolfram Alpha. Does it not show Wolfram Alpha? Why is it showing the wrong? Oh, you know what? I think it froze. Yeah, I don't know what's wrong with my OBS. I think the screen sharing froze. Huh. Okay, well, I guess we're not doing that. Well, yeah, let me just check. Works best for 3 to 10% area. Yeah, rule of 72, you have to be, it's estimating log of 2 over log x as 72 over x. Yeah, so you're using a linear to estimate a log, right? Okay, yeah, sorry. Let me just type this into the computer. I want to show it on the screen, but I think my OBS is actually frozen, so it won't let me show it. But it's 1.4589 to the 1/5 power, and then minus 1, and we get 0.0785. Okay, so that's about a 7.85. Oh, sorry, not linear, my bad. Yeah, you're right. Not linear. I guess it's estimating it as the derivative. Oh, right. But the derivative is changing. So what? That's the derivative of 1 plus x at 0 or something? Or the log of 1 plus x? Okay, but either way, we got our answer. So Jeff says rule of 72 gives us an estimate of around 7.2%, and it was slightly higher than that. So not too bad. And CAGR is like a finance word. This means compounding annual growth rate. So this is the growth rate that if you compounded it annually, it would be equivalent to the total return, which is this 1 plus this 45%. So basically, Tesla went up, almost 46% in 5 years. But if it had gone up some constant percentage every year, that percentage would have to be about 7.85%. And if I compounded that 5 years, I would get the same return over the 5 years. Which is saying that, Tesla isn't too great of an investment over the last 5 years because you're only getting about 8%. I think the S&P average is around 10-ish. So over the last 5 years, the average compounding growth rate has been lower than the S&P, and also the volatility is much higher. So if you just look at the last 5 years, then this is not a good investment, according to the Sharpe ratio. But, you'd have to calculate it all out. But yeah, now compute the volatility. Okay, yeah, by hand. I think the volatility for Tesla is like around 60 or 70% though, so you don't want a stock that's this volatile if it's only giving you, it's actually not even giving you as much return as like a S&P or like some index fund, right? Risk-free interest up to 250K was lower though. Right. Yeah. But this is a lot more than. So you're getting slightly more than your risk-free rate. I think the risk-free rate right now is around like 4 or 5%, right? So you did do better than just putting your money in like the bank, right? But you took a lot more risk because I think at one point, maybe the stock dropped like 60 or 70% a couple of years ago. So yeah, this is what you think about if you're doing investments. Like, what's my average rate of return? Is it better than the risk-free rate, worse than the risk-free rate? And how, is the volatility worth whatever risk premium that the stock is potentially going to give you in the future. Unless you're selling covered calls. Yeah, of course we can get into the covered calls eventually. Covered calls, you're still taking some risk on the covered calls because you could sell covered calls and then the stock goes to zero. So it is possible. I mean, you can make all your money on the premiums, but then your stock goes to zero. You still lose a lot. So okay, I think that's it for today. Unless anyone has any interesting questions or directions that they want to take, we could talk about a little more finance stuff in this direction, or any type of probability questions. I mean, I could do another question if we want, but only if there's something interesting to go over. Black-Scholes doesn't allow the stock going to zero. Yeah, that's true. Yeah. I'm trying to make a funny comment here, I guess. Yeah, Black-Scholes doesn't include the stock going to zero. But I mean, of course, you can always include a jump model where you just include a jump component where there's like some non-zero probability at any moment that it could go to zero. You can add to the Black-Scholes model. You can add a component that would allow it to go to zero. But that would change all the formulas, of course. Can I ask a quick question? I understand chain complex. Then can you explain me cochain complex? Yeah, sure. I can do that. So bailouts are inevitable. Yeah, according to Black and Scholes. Well, actually, the funny part is Black and Scholes. Zach, do you know the story about the people behind Black-Scholes and long-term capital management and all that? I mean, because that literally did happen. Like, their models didn't work, and then the government bailed them out. So that actually literally happened. Yeah, I can go over co-boundary map for sure. But what if I just really like the stock? Yeah, I mean, if you really like the stock, then I mean, if you really like the stock, though, you would have to hope that in the future this CAGR is going to increase, right? Because you can't afford the volatility of Tesla if you're only going to be making less than the S&P forever, right? So whatever model you're coming up with that you're justifying buying this stock, it would have to include that the CAGR is going to increase more than this in the future. Okay, yeah, so somebody wants me to talk about I don't know how much you want me to say about cochain complexes. I mean, really, you should really study the dual space of a linear map first. Without that, it's going to be a little bit confusing, but all you need to know about the cochain complex is that it reverses the arrows. So if you have a map between two different spaces, you get a map between the cochain complexes, but it goes the other way. So normally, yeah, so actually I didn't say this last time, but maps between topological spaces or simplicial sets induces maps on the homology in the same direction. So like, let's say we have a map between two topological spaces, or a simplicial map between two simplicial sets or something. This induces a map on the homology spaces, or the homology groups. But it also induces a map backwards from the cohomology groups. So it reverses the arrows in some sense, like that. So that's one thing about the cohomology. There's like this Tor theorem. What's the name of it? The universal coefficient theorem, I think. So there's a relationship between the homology groups and the cohomology groups, but you have to look at this. Actually, I think it's is it the home functor or the Tor functor? One of those tells you about the relationship between the homology groups and the cohomology groups. But there's this like X relationship. Yeah, so the co-boundary map, I mean, that's just the dual of the boundary map. I mean, there's nothing really too crazy about that. Yeah. Home and the obstruction is X'd. Yeah, exactly. Kyler's got the right idea there. I missed some stuff. Whenever reality disagrees with my model, I reject reality, of course. The model is never the reality. No reality is accurate. Some realities are useful. Yeah, I think Black-Scholes is useful, even though it doesn't include... I mean, there's a lot of things that Black-Scholes is leaving out. I mean, in a real market, you don't have a single price for a stock anyways. You always have you have the lowest price that people are selling it for, which is usually not equal to the highest price that people are willing to buy it for. So in reality, there's not even a single price for a stock. So Black-Scholes right off the bat can't be a model for reality because it says there's only one particular price for a stock at every moment in time. But that's simply not the case because there's one price for sellers and one price for buyers, and it's never the same price. So I think you need the chain complex to be built from free modules. Right, or else you can't do that stuff. But all the stuff that you use for homology and cohomology, all that stuff is free modules because well, these aren't free, right? But the chain complexes themselves are free. Volatility smile is the best indication Black-Scholes doesn't work, right? Bid ask are usually tight. Yeah, it depends on what you're trading though. I mean, for some options markets, the bid asks are not tight, and some stocks that don't trade that much, the bid ask isn't that tight. I mean, you're thinking of like blue chip stocks, and for those, you're right, but that's just not true for every market, you know, especially stuff that's not traded as frequently. Some stuff only trades, a couple times a day. You might be dealing in like private equity type stuff, right? Maybe there's people only trading like OpenAI stock like once a day or something, right? So there could be a big bid-ask spread there. And the less the stock or the asset is traded, the less Black-Scholes will be an accurate depiction of it, because for Black-Scholes to replicate the Black-Scholes portfolio, you have to be trading continuously. So there needs to be a single price, like infinitely small spread, and you need to be able to trade at every possible price change, or else Black-Scholes is not accurate. So yeah, that's the problem. That's what dynamic pricing is trying to solve. Yeah, I mean, that's dynamic pricing is like your dynamic pricing is the same algorithm as market making. You're trying to say how wide of a spread should I take, and how much should I move my bids or asks up or down based on how much I'm trading, right? How much activity there is. I'm on like two different tangents here. Slight GPX2 says, okay, so what's the point of cochains? It's like for scaling? Well, like I said, the cochains reverse the arrows here. So you're restricted on what type of continuous maps you can have between these two functions, because they have to induce maps on the homology groups, and it has to induce a map backwards on the cohomology groups. So you're restricted on the fact that this needs to be a group homomorphism, and for certain groups there may not be many group homomorphisms at all, or if these are just trivial, right? There may only be the trivial map between them or something like that. So this information, the fact that there's a group homomorphism here and here, that gives you information. And also this is a map of, I believe, rings too, if you're working over a coefficient ring, or even if you have Z, it's still a ring. Is finance your plan B from academia? No, I already did finance. This is my plan A was finance. This is my plan B. Yeah, I already went the finance route. Diamonds and spiders. All right. Well, yeah, I mean, I don't think I have much else to talk about today. I think we're good on the problems here, and I'll probably end it in a little bit. But yeah, any other stuff about cohomology? I guess we were really talking about two topics here. So if anyone wants me to expand a little bit, I can, but I was talking a little bit about cohomology here, and we were also talking a little bit about some Black-Scholes. So if anybody has any questions about these two, I could expand a little bit more if we want to keep going, but you're doing the reverse start. What do you mean by that? You have a more involving spectral sequence. Oh, you're talking about the spectral sequence, what you would need for if they weren't free, you're saying? If the cochain and chain complex weren't free? Will I do my the dice problem? Can we save that one for next week? I kind of just want to talk about these two, or just end it. Finance first. Well, I guess first was to teach math probably. Then I wanted to go into finance, maybe start a company or something. Now I'm just doing this for now. Hey, sorry, I just joined. Would you mind defining what a cohomology is or what area this is used for? Yeah, so this is to study topology. So usually we're studying either continuous maps between two topological spaces, right? This is like, they could be a ball and a torus or something like that. And we define certain homology groups, which were like free groups based on these n-dimensional triangles in the space. And there was a way to define homology, and it turns out that if you have a map between the two spaces, you get an induced group homomorphism here between the Z modules here, which are groups. You get a group homomorphism between these groups from the X1 to the Y1. But you also get a ring homomorphism, or in general it'll be an R module, or an R algebra actually, homomorphism between the cohomology ring of the Y space to the cohomology ring of the X space. And like I was saying before, this restricts what type of continuous maps you have here, because every type of continuous map here induces a different ring homomorphism, or potentially a different ring homomorphism. They could all be the same, right? If this is just a point, for example, then it's kind of boring. So if Y is a point, then this group is like trivial, except for the zero group is just Z. And yeah, actually, you could think about what this is if Y is just a point. But I believe it's just the zero map. Maybe? Yeah, I think it's the zero map. Well, I mean, it would have to be the zero map, right? Oh, no, it doesn't have to be. Oh, wait, no. Because if a point maps to a point, then that would actually be the identity map. All right, yeah, you need to think about like that. That's exactly why you think about what happens here. Like if Y is a point, this is the integers. If X and Y are both points, and these are both the integers, then that induces the identity homomorphism, I believe. Yeah, so any other questions? So basically cohomology is just this algebraic tool where we build groups based on the spaces. And it sort of simplifies some stuff in a way because we have tools to deal with these, like group theory to deal with these. And group theory is somehow more like well defined or well set in stone what's going on in those cases. And so we sort of translate information about topological things, which are, topological spaces and continuous maps, into stuff about algebra, and then we try to reason about either the dimensions of these spaces if they're vector spaces, or just try to reason about what types of group homomorphisms or ring homomorphisms exist between these. So once you see cohomology once, you realize everything becomes cohomology. Yeah, but the notion is you're trading in the space for some sort of chain complex that is in some sense like containing all the essential information, but now it's in a group form. So you're sort of like groupifying your space. It's this somehow you want to think that like this topological space is maybe somehow hard to understand for certain spaces, but the group version of it is maybe more well understood. So that's the hope. So sorry, my knowledge of topology is limited. What are the restrictions on X and Y in order for these to be homologies? There's really no restriction on X or Y. So these exist for any topological space or simplicial set. And any continuous map or map of simplicial sets induces these group homomorphisms, or ring the other way. They're not any groups. They actually have to be abelian groups, so that's very important. They're actually Z modules, which are abelian groups. Or in general, if you have a coefficient ring R, they'll be R modules, meaning that they're an abelian group, but they also have this R action, like a vector space. And in the cohomology, you actually have a ring because there's a way to multiply the cochains. Here you actually have you have a coalgebra structure here, which is also interesting, which shows up in my research as well. This coalgebra stuff. Well, the ring structure does too. There's actually an E infinity structure as well. So you have a coalgebra here, but there's like higher coalgebra stuff, and if you take the dual, you get higher like E infinity algebra stuff going on here. So I think this will actually be a map of E infinity algebras, if I'm not mistaken, as well. So this will be a map of E infinity coalgebras, and this will be a map of E infinity algebras. So you have more than just the ring structure. All right, I think I'm going to call it here. Let's see. I'm getting pretty tired. I don't think there's any chats I missed. Yeah. So cohomology, cool stuff. I think I'm going to chill with the financial stuff for now. I did about 9 videos. We proved a central limit theorem, and then we took a limit of that binomial model for the stock where it's multiplying up or down. So I'm thinking either complex analysis next, or I don't know what else I should do. We did probability, linear algebra, calculus, group theory. I could get into ring theory, so it's probably either I'm going to do next probably complex analysis or some like ring theory or modules. Something like that. But I'm thinking complex just because it's fun. Okay, I got a couple comments in the chat. Wait, I read that it's connected with Stokes' theorem, kind of the same as delta F TETA equals F of, is that supposed to be delta? Oh, delta F. I'm a little confused what you're saying there. Oh, I see. Yeah. Stokes' theorem is related to cohomology theorems through the de Rham theorem. So here, let me put this in the chat. This is interesting stuff. Yeah, so this is cohomology, how cohomology is related to de Rham's theorem, or sorry, not de Rham's, to Stokes' theorem. Yeah, so if you're interested in that, I put the link there, de Rham theorem. So there's also a pairing. Well, no, I think this is the de Rham theorem, or I'm mixing up theorems, but yeah, there's some sort of intersection product where you can take a cochain and a cycle, and yeah, I can't remember the whole story, but you can look it up. But yeah, there is a something related to Stokes' theorem, and you have like closed forms, exact forms. So closed and exact forms are very related to cohomology ideas, where you have You can look into it. Yeah, de Rham theorem is what you want to look at though. Kyler says, I like in AG we have Serre duality for reasonable space, which is a result on cohomology, but this can fail for highly singular spaces, and you can build the dualizing complex that measure the obstruction for Serre duality to fail. Yeah, I'm not too. Serre duality is the the n minus I homology groups are isomorphic to the ith ones or to the ith cohomology, or I can't remember the exact statement, but yeah, doesn't Serre duality not work if the manifold's not compact or not closed, right? What do you need? I think you just need closed and compact maybe, and then it works. But I think most of the manifolds you deal with in practice are closed and compact, because if you want to be able to write down like a finite simplicial set that's equivalent to that closed manifold, then the only way it's gonna be a finite simplicial set, like built out of a finite number of triangles, is if it's closed and compact. Otherwise, you could just be going out to infinity in some direction or something if it's open. And it's a condition on a local ring. Oh, to get Serre duality. Oh, for the ring you're saying, but the Serre duality, I think there's some conditions on the space as well, though, right? You're talking about the spectrum of a local ring, or wait, is there Serre duality for schemes as well, or I forget how all that stuff works. I know Serre duality for like closed compact manifolds, I think, or closed compact Kyler stuff too, probably complex stuff. Okay, I'd like to talk about this stuff all day, but yeah, I am a little bit tired, so I'm gonna call it here, and let me end the recording. I'll say bye to